Okay, so the way that you can start is that, let me see if I can do it from my, maybe not here, but if you were to go to my website, right, you're going to see code, and you're going to go to ANN. I'm missing this one, right, LLM, so hopefully I can make LLM soon, okay? So ANN, and you go to classification, okay, and we're going to, can you double click in here? Does it work? It should start up Google Colab for you. Okay, and before you hit run, I mean, if you hit run, that's fine, right? But before you hit it, can you, so normally I want you to own this file. So right now, if you open it from my link, you don't own it. You can, I mean, whatever you do will not get saved because it's not your own. What you can do is you can save a copy in drives. That's one way you can do. Or if you know, we're going to do this a bunch of times. There will be many, many files. If you get too lazy, all you have to do is to just copy the whole thing, like the whole maybe ANN. Just download it and put it into your drive. Like if you own the file, you can open from your drive and just use the file and it gets saved, you know, like your progress will be saved. So I do recommend owning the file, like owning the copy of it, right? So figure a way to do that. Like you can download it first, put it back into your Google Drive and run it from there. Okay, so take some time to figure it out, right? I'll give you some time to figure it out. No, you don't need to use Visual Studio anymore from now. Because TensorFlow is very picky. It does mess up your normal installation. So if you want to do TensorFlow, I recommend you create like new environments that's specifically for TensorFlow. But that will take some time, so I don't want to, I'm kind of rushing time, so you can always use this one for now. That will be, if you want me to help you after class or outside class, I'll be glad to help you. Okay, you want me to wait?เดี๋ยวขอ stop ก่อน Use the online version, but I'm going to use my local machine because if it breaks, I can figure it out how to fix it. So I already installed TensorFlow into it. Right. Okay, maybe we can go through one example. Okay, so we're going to do new file. Okay, C1. All right, so in Python, again, very premier tool for machine learning. There's a library called TensorFlow, which is developed by Google. That's very, very popular, the library for doing, you know, artificial neural network stuff, deep learning, and all kind of things. But keep in mind that TensorFlow is actually not the not the tools that people use if you want to go if you want to stay at the edge of AI. TensorFlow is not what you want to do. TensorFlow is anything that gets established will get ported into TensorFlow. For example, like models that are like image, you know, traditional ANN, and even some of the transformer model, they do include it. But if you want to stay at the very edge of it, like you want to do like DeepSeek R1 stuff, TensorFlow will not have it. You got to go to PyTorch. Okay, so let me show you that are two library that you might consider in the future. So TensorFlow, this one is for much mature stuff, you know, anything that classic and widely used, TensorFlow. But if you want to stay at the very edge of the technology, you got to use PyTorch. This one is a bit more complicated to use. You have to understand the class system in Python, but researchers always use this one first. So that's what it is. Okay. I don't know much about PyTorch. I tried, and I kind of gave up, but not because it's too complicated. It's just because that I can do a lot of things in TensorFlow, so I don't need PyTorch per se. But it does require some learning curve for it. And I'm wasting my time. It's almost noon. It's noon already. So okay. So first off, I want to import it. And if I recall, you guys should click and see if it's running. If it's not running, also let me know. It does take some time for the Google Colab to get started. So do start it. Okay. At least the import cell. And this one takes about a minute to import. So as you can imagine, this one is a huge library. It takes up to like 2 minutes to import in my laptop. Takes about 2 minutes. Okay, done. All right, so first off, we're gonna see, we're gonna use the iris dataset. That's the first one we use for Ceptron, and now we're back at the same place. This one, I'm actually using the function load iris. This one from scikit-learn though. I'm still using data from scikit-learn, even though I'm using TensorFlow. There's nothing wrong about this. Okay? And I'm going to put all of my data into the data frame. Okay, so this one, again, putting the data in the data frame and then the column names. Okay, so df, I got all of this. Okay, ready to go. Okay, and then I also want to set my target, which is my y, to become the like that. So if I do head, I will see that there are 5 columns, right? 4 of them is my x, and then this is my y. Okay. All right. So the next step is something that we need to take care of, because right now the way that the data are organized is it's organized by the target. If I were to see df target dot value, you can see that my target is actually grouped into 1, 0, 1, and 2. They're not shuffled. So if this is the case and you input this data right into TensorFlow model, it will kind of mess things up, because it does take order of your sample into consideration, and it will use the last set of your data for validation. I kind of skip the validation steps. So it's just a way to make sure that your data, your model is doing okay during training. Okay, but if you have the data like this, then you only validate the class number 2. So I want to shuffle all of this data, and Panda already has a very simple utility for that. It's called df.sample. Right, so this one, df.sample. When I say frac equal to 1, that means that I want to sample everything, so I don't want to lose any data, but I just want to shuffle my rows per se. So if I were to use this, then I can see that my df target, right, dot value will be equal to, now it will be randomly shuffle. I mean, random shuffle is wordy, just shuffle, right? Okay, and next I wanna extract my value. x and y, right? So I'm going to use this operation right here. So this one is just saying that I want to use the column number 2 to 4. Oh, so the last two columns for the x value. So this one I want to visualize things. So I need 2 x's. Okay? And then my y will equal to the last column, which is the df target, right? Dot values. Okay? Again, you don't have to only pick 2 columns in here. This one is just for visualizations. But you can also pick all the columns, which you should do, right? You should go back and experiment with what happened if I use all the x's, right? And the next thing is what we did all the time, right? Splitting into train and test. Okay? With the train test split function from scikit-learn. That's the one, right? And then next, I'm going to do standard scalar, right? Please do not forget this one. This is very, very important, especially for neural network. You know why? You know why this is especially important for neural network? Think about this. I guess I might be, okay, maybe we might talk about this a little bit more in regressions, but it's the same thing. Think about the neural network, especially if you use sigmoid function, right? The sigmoid function will always output something between 1 and 0, right? But if your input is so different from 1 and 0, then your weight is going to be either really, really large or really, really small. So that's not good for your numerical stability. So I guess in the world of neural network, if you can keep your number in all of your operation around zeros and 1, that's the best way. So I guess you want to tame your number down. So that's kind of the benefit of standardization. In addition to the fact that I mentioned before, right? You don't want one of the x to overpower the other ones. But actually for artificial neural network stuff, there is also numerical stability that you can be concerned of. So as you will see, like once we go into like deep learning and stuff, there will always be steps like normalization. And that's tame things down so that it doesn't blow up in the calculations. Right? That's, again, just use it, man. There would be very rare case that you don't want to use this, I guess. All right, so next is going to be the fun part, right? Okay. The fun part is this TF, right? We're going to build the neural network, right? And the way we built it is that we're going to build it in sequence of layer, okay? So we're going to use the function called, not the function, it's the class that is called, so tf.keras.sequential. So that is a function that we want. Sorry, not the class that we want, okay? So one thing is that, what is keras, right? Why is keras here, right? Keras is actually another library in Python neural network stuff, okay? But keras, so before I guess maybe like 7 years ago, when all of these things just getting started, there are many libraries that get created. TensorFlow was one of them. Keras was another one, and they're fighting one another. They're competing with one another. But nowadays, TensorFlow already include Keras in their API. Maybe they buy it, or maybe they merge together. I don't know what happened, but eventually Keras on its own, just nobody used it. But Keras just get added to TensorFlow. So that's why when you say tf.keras, it's like you are accessing the Keras library that get added into TensorFlow at some point in the history of like all of this. Okay, just a little thing to just in case you wonder what Keras is. Okay, all right. So in here, if I want to create my network, I want to create a layer one at a time sequentially. So first, I want to do tf.keras.layers. Okay, so it's the module, as we call the input layer. Okay, so no surprise, right? We are creating the input layer. And this one, we're going to have to specify how many inputs do we have. Right now, we only have x1 and x2, right? You can go back and see the shape of your X. So I want to put input shape equal to 2. I'm going to turn this thing off. This is kind of annoying. Okay, the AI stuff. Okay, all right. So as you can see that the API is a bit complicated, but just see the overall picture, right? We are building the input, the first layer, the input layer. That input layer doesn't do anything in terms of calculation. It's just there so that we can keep track of how many inputs do we have. So if you were to have 4 things going in, then you would do 4. That's all you do. Okay. And you know, you can also input things in matrices too, if you want. It doesn't have to be vector, it can be matrix. So that's why you have the option of, that's why it's, you know, and you know that the tensor name is from this particular things, right? Because when you have series of number in mathematics, you have vector. When you have the 2-dimensional vector, you have matrix. But then when you have more stuff, more dimensional, higher dimensional matrices, it's called tensor. That's why this library is called TensorFlow, because it's like tensor flowing through the layer. Okay, in case you're wondering, right? That's where it comes from. Okay, all right. So next up, I want to do the hidden layer. So I want to do tf.keras.layers, but now I'm going to do the dense layer. So dense is the generic term for what's called the fully connected layer, like, and you'll get used to it. So dense is the generic term for fully connected or like hidden layer. Okay, and you can say unit equal, like, so that is number of nodes. So I want 16 nodes. You can have more or less, up to you, doesn't matter. Activation, now you should be able to choose which one you want, right? We have choices between sigmoid, hypertangent, ReLU, and leaky ReLU, and a bunch of things in the literatures. We're going to do sigmoid first. And you got to give it a name, so hidden one. Okay. Let me just, I guess no, I don't need to skip, but I need the output layer. So keras.layers.dense again. So the output layer is the dense layer. Unit equal to 3. So this one pays special attention to this, right? I'd say unit equal to 3 because I need 3 classes. That's the reason. Okay, so be aware that this number is going to be fixed to the number of classes you want to predict. Okay, and then the activation equal to soft max. So that is something that you want, right? Take a special notice in here. The reason that I choose soft max is that in our discussion about classification, you have to convert your output into probability distribution. That's one. You got to do softmax. So now you cannot just not do anything. You have to do softmax, okay? Or else it doesn't work. All right, and then the name is going to be output. All right, so let's do it, okay? So I'm done with the units, right? I forgot units. Units with S, okay. All right, I can do model.summary. Oh, I forgot to put this in my model. So model equal that. Now you can start seeing, you can see something like this, right? So this one will tell you it's a table that summarizes the layer in your ANN, right? And I want you to notice that the input layer does not get specified in here. That's kind of normal. You know, I mean, for me, it would be nice if they include the input layer, but they don't, right? But they're including everything that's, you know, after the input layer. So we have hidden layers and then the output layer, right? So one thing you want to take a notice is that the number of nodes is 16 and 3. So that's what we specify, right? I'll talk about what is none right here. It's kind of confusing, but I'll keep that for later. And then this is number of parameters. So this is how complex your model is going to be. So right now you are training 99 parameters, so weights and biases, 99. So we don't have time to go through the whole thing, but I want you to get your hand dirty on building the neural network. So why don't we just do another hidden layer? What would happen to the number of parameters? All you have to do is to copy this and just come up with another number, right? Any number is fine. People just like to do the multiple of 2, but you don't have to do that. Just go crazy. The only thing that you need to make sure is that you don't want the name to be the same, or else it's going to complain, right? So if I were to run this, now I have 3 layers with about 700 parameters. I want you to go crazy. See how much, see different architectures that you can build from just this line alone. So try changing it and see what's happened. And that is exactly what I would expect if you were to, I guess, try to convince me that you want to do ANN. You need to think about this kind of thing, right? Or else it's too broad. Like what is your architecture, right? This can be your scope of your study, right? You want to do ANN, but you want to limit the parameter size to maybe less than 10,000. So that might mean that you can run your model in the laptop, or you have to run into like supercomputer, or you want to do maybe max of no more than 10 layers because that will be too deep, right? Or you might want to keep your I don't know, your input to how many units of input or outputs and things like that. That if you have this kind of information, then you can convince me that you know stuff, right? Instead of just saying, I want to use ANN, and then it's too broad. Right, so I don't know. Show me your architecture. I want to see what you come up with. อ้าวรันแล้วเหรอครับ
ลองแล้ว
มันก็ไม่ได้เยอะมากแต่มันก็รันนานนะคือถ้าคุณลองคิดว่าถ้าเกิดคุณมีโมเดลแบบนี้แต่เป็นแบบ random forest อะคือเสร็จไปตั้งแต่เสี้ยววินาทีแรกแล้วอะแล้วนี่คือ Data ไม่ได้เยอะนะนี่คือ Data น้อยมากนะถ้า Data คุณเยอะกว่านี้คุณก็รอไปเถอะเนี่ยนี่คือความเศร้าของ ANN ถ้าเกิดคุณจะเล่นมันรอนานไหมครับอ๋ออันนี้ก็ learning rate ครับก็เดี๋ยวยังไม่ถึงเข้าหน้าแล้วกันแต่ว่าขอดูโมเดลหน่อยว่าทำอะไรไปของตรงนี้หน่อยอ๋อไม่ทำโอเคแก้ได้ครับโอเค just anything good โอเค actually about 1,000 is still relatively small you can go crazy than that so you'll see if you start to adjust like just one number in the hidden layer things will blow up a lot like just one layer, you'll see that it does change a lot. Now you get almost 2,000, right? Now, if you change 2 layers at a time, then it just like the things will multiply, and that's the complexity that you will have to deal with. You have 3,000, right? Yeah, something like that, right? Mm-hmm. And if you're curious, you can try running it to see how slow it is. You can just run all and see how slow it's going to be. It's actually slow if you compare with the traditional machine learning model. It's quite slow. Mm-hmm. Unless you have a good hardware, maybe you're lucky. Okay. All right, I think maybe I want to stop now. Maybe I'll continue later for the actual running and further discussions. All right. Thanks a lot, guys. Mm-hmm.
Who we call that? The calculation power comes from Google?
Come from Google, yeah. So just a tip for you guys. If you think that you need more, you can choose GPU. So this one is running on CPU hardware, but I think you can request for GPU somewhere in here. I don't see it anymore. I remember that if you click at the connect, then you can, change runtime type. Yeah, see this one? You can use one of the more advanced, like a more specialized hardware. But this one doesn't guarantee all the time. Sometimes you don't get it because it's gone. It's all used up. But you can try. If you use like GPU, then it does speed things up. So right now, this one is running on the server. It's called a virtual machine. It's running on CPU. But you can change your hardware so that your code gets run on GPU. So that will be faster. But this one doesn't always available. So you can try because you don't have to pay anything. Google let you do it as long as there's a pool available, right? But if you need more, you can always pay, right? You can pay $10 per month and you get access to some of these. Limited amount though.
Like when I want to,
You can do Pro, Google Colab Pro. You can subscribe for it and you get access to like even better hardware.
when I want like my vehicle routing problem with Garobi, what do you recommend me?
I mean, you can try, but it also depends on the library. If the library cannot use GPU, then you're out of luck. So yeah, that too. But that's not hurt to try, right? Just try to see if it's faster. Right? And I would say that it's